Hello everyone, today we're going to continue our conversation about proving triangles similar. As I mentioned, we have 3 methods in total. So in previous class, we mentioned first 2 methods. So before we start the lesson, let's quickly review what the first 2 methods are. The very first method, as I mentioned, in order to prove 2 triangles similar, we just need 2 pairs of angles are congruent, which as you can see in the picture, so all we need to prove is angle A is congruent to angle D, and angle B is congruent to angle E. Then we can come to the conclusion triangle ABC is similar. Do not forget this is a similar symbol. Triangle DEF. Okay, so that's how do we prove the 2 triangles similar for the first methods, which we call them AA similarity. As you can see, AA stands for 2 pairs of angles. So let's check the second method. Second method, we are talking about using sides only. And this time the keyword is 3 pairs of corresponding sides are proportional. Proportional meaning they have same ratio. So all we need to show is 3 pairs of, that's the first pair AC is matching to DF. And the second pair is AB is matching to DE. Third pair is BC over FE. So the ratio we can put in a fraction. This expression telling us, this equation telling us the corresponding sides. That's the first pair corresponding sides, second pair of corresponding sides, third pair of corresponding sides are having same ratio. Then we can come to the same conclusion. These 2 triangles are similar. So that's why, since we call 3 pairs of the corresponding sides, that's why we call this SSS similarity. Please pay special attention about SSS similarity, which is in congruence. We know there is another method called SSS, but in that case, we need 3 pairs of corresponding sides are exactly same. But this one, in order to prove similar, we need them to be proportional. So before we introduce a third method, the last one, let's quickly review a word we mentioned before, included angle. So included angle is based on the position of the sides. So let's say this one. I'm going to use a little bit bold line here. And for example, I'm talking about these 2 sides. Then the included angle is talking about the angle between these 2 sides. So the angle between 2 sides is called included angle. Let me write down here. Let's just quickly. So the angle between 2 sides. So as I mentioned here, in the triangle, if I'm talking about 2 different sides, then we are talking about 2 different, different included angles. So let's use a different color to show. If I'm talking about this side, let's use a bolded line. It's easy to see. So this time I'm not talking about the red one. I want you focus on now is a green one. So as you can see, the green side is talking about this included angle. So that's different perspective. So remember, there's no fixed position for included angle. When you change the size you are talking about, then you are talking about different included angles. So please pay special attention for that position. Now let's quickly check the very last method. What's the definition? How do we use it? So this one says 2 pairs of corresponding sides are proportional and their included angles are congruent. Then we say these 2 triangles similar. So besides in definition, let's quickly check the pictures here. So we have 2 pictures, as you can see. For AB and DE, they are, as we can see, it's clearly they are corresponding sides. This ratio is 5/10. And another side we know is AC over DF is 6/12. So if we simplify that, you will get this is 1/2, this is 1/2. So it seems that the size is doubled. So they have the same ratio. And then for the included angle, as you can see, this time I'm going to use a border line here again. There's two sides. The included angle is here. So that's why their included angle are both 60 degrees. So that's why they are congruent. So let's write down the conclusion. So we know AB over DE equals AC over DF, same ratio. And then angle A is congruent to angle D, included angles. So that means triangle ABC is similar triangle DEF. Okay, so this one we call the method as you can see is side having same ratio, angle, and then side have same ratio, so we call SAS similarity. Again, as you can see, the name is actually same as the other method, which called the SAS incongruence, but this time the sides are proportional, which means they have same ratio. So this one is called by SAS. Do not forget to put similarity, which is in demonstrate this is a similarity situation here. Okay, so I'm going to the first video we are going to first review the two methods, and also we introduce the last method. In next video we are going to practice several examples to readdress your understanding for this method. So quickly see you later in next video.